Myself Dr. Jeevitha from Department of Physics. Today we are going to see the topic ND-YAG laser. So what is ND-YAG laser? ND-YAG laser, it stands for ND is for neodymium and YAG is nothing but yttrium, aluminum and granite. So here we are going to dope ND-YAG into yttrium because ND-YAG is a ion of 3 valence, and similarly we have yttrium also, its a valence is 3+. So we are going to dope yttrium into Nd, right? So here the principle is the active medium is ND-YAG rod, which is optically pumped by the krypton flash tube, and neodymium ions are raised to excited state and it will release the wavelength is 1.064 micrometer. So here we are going to see the construction using the diagram. So if you see the diagram, it is an elliptical cavity. Inside the elliptical cavity we have laser rod and flash tube. Laser rod is that we have used ND-YAG laser, and flash tube, that is krypton flash tube. So if you see, the krypton flash tube is connected with the power supply using the capacitor, power supply and resistor. Why we are using this inside the elliptical cavity? We can keep the flash tube outside also, but the entire light source will fall onto the laser only with that vacuum. So the light will not escape from that cavity. That's why. So, and that was connected with the power supply, and the cavity, both the side of elliptical cavity is placed with the reflecting mirror. So one end is connected with the 100% reflecting mirror so that the laser light will not go outside, and another end it is partially reflecting mirror. So once we have switched on the power in the flash tube, the light will start glowing and the light will fall on the laser rod. Once the light is fall on the laser rod, there is a transition will happen. What transition will happen? The electron absorb all the energy from the ground state and it will go to excited state. After a certain time, it will again come to the ground state by releasing its energy. So here we can see by this diagram, this is energy level diagram. So usually in the ground state all the electron will stay. So when we give some energy, the electron will absorb the energy and it will move to higher energy state. From the ground energy state, it is moving to the higher energy state. So here we have energy level 1, 2, 3 and 4. So the electron will absorb all the energy and it is going to the excited state, energy level 3 and 4, and it will not stay more time in the higher energy state. It is coming to the lower energy state. So once the electron is absorb all this energy and it is going to excited state, at certain time it is releases energy and coming to the E2, which is energy level 2. So there we'll call that energy is a metastable energy. Here there is not more stable or not less stable also. If we are giving some more energy at that time, it also will releases energy and come to the ground state. From the lower energy, it is going to excited state, energy level 3 and energy level 4, and it is coming to the metastable. From metastable, it will release some wavelength and it is coming to the ground state E0 without any radiative transition. So, and the application of this ND-YAG laser is used in medicine, industry, military and scientific. So in medicine we can use this is for eye surgery and dermatology, and industry will use this for cutting and welding of the material, any material, and military it used to find the range finder and target the designation. And the advantage and limitation is, the advantage is it is high power output and reliable and efficient, and the limitation is needs cooling system and setup can be costly. Thank you.